Look at solving equations and inequalities, and we're going to look a little bit at two variable equations. The biggest thing to remember when we're solving equations is we have to isolate the variable. We're trying to figure out what our variable represents, so we've got to get it by itself. And the way that we do this is through doing the inverse operation, or aka the opposite. So I have this first example right here, and it is 3y equals negative 15. So eventually I want just y equals. That's what I mean by isolating the variable. So to do that, I can see right now I have this 3 over here with my variable, and it's multiplication. So I'm going to do the inverse. I'm going to do the opposite. So instead of multiplying by 3, I'm going to divide by 3, and that cancels those out, because 3 divided by 3 just gives you 1. Well, we remember when we did this a while back, whatever we do on one side of an equation, we have to do on the other side as well. So if I divide by 3 on this side, I've got to divide by 3 on the other side. And we know that negative 15 divided by 3 is negative 5. So y equals negative 5 in this situation. And remember, we can always plug this back in just to double check. 3 times negative 5 equals negative 15. And that is true, so we know we're right. So the next one is an example of an inequality because it has a less than sign, but we're going to solve it the exact same way. I want b by itself at the end, and to remember at the end, it's not going to be an equal sign, it's going to be a less than sign. So I want to figure out b is less than what? Well, right now I have this negative 7 over here, and the way that I'm going to get rid of that is by doing the inverse. So I'm going to add 7, because I know negative 7 plus 7 cancels out. And then on the other side, I've just got 32 plus 7, and we know 32 plus 7 is 39. So b would have to be less than 39 to make this true. And if we plug in, like let's say 0 is less than 39, that's a number that we could choose. So if I had negative 7 plus 0, that's going to be negative 7, and we know negative 7 is less than 32, so that also works. All right, on to our next one. This is a two-variable equation, and remember, we always have an independent and a dependent variable. So our independent variable is always on the x-axis, and our dependent variable is always on the y-axis. So independent and dependent. And if you look at what those actual variables are, or what the labels on those axes are, I have total meals packed and I have time. Well, that would make sense that the total meals packed depends on the amount of time that they spend packing them. We can also tell, just by looking at this graph, since it goes through 0, 0, and it's a straight line, we can tell that this is multiplicative. So it's going to be a multiplication equation. So the way we're going to actually figure out what this equation is we're going to make our own table. We're going to make an XY table. If you don't have a graph, they just give you a table, this is where you get to skip the graph part. But we're going to find, I always say, let's find 3 points on the graph. So obviously the easiest one's probably going to be 0, 0. Then I do ones that are right easy on two numbers. So I have one on 2 and 250, and then I have one right here on 4 and 500. So there's my 3 points. Remember, we're trying to find the rule so that we can write our equation. Well, I know it's multiplication or division since it has a 0 and a 0. So I'm going to divide those two. I know that 250 divided by 2 is 125. And I know that 500 divided by 4 is also 125. So I'm multiplying by 125 each time. So my rule is going to be times 125. So remember, our equation is just our rule with our variables. So I'm multiplying x by 125. So I'm going to do 125x, and my result is y, or the dependent variable. So that's my equation. So remember, on two variables, you're just using the table to find a rule. If you have a graph, you're going to have to make your own table first.